What would you say if I told you the enormous power of a fusion reactor could be contained in a plastic barrel? Would you tell me it's a complete fabrication? What if I told you that a machine could capture the photonic result of defeating the nuclear strong force? Would you tell me I made it up? Join me as I build an object that can leverage the results of stellar fusion to the benefit of all humanity. A few weeks ago, I finished my e-bike conversion and took it out for its first voyage. In less than 2 miles, I managed to break the rear derailleur. While I waited for the replacement parts to arrive, I wondered how I could charge it without using any electricity from the mains at all. I started looking through Gumtree and found a polyethylene watertight barrel for a couple of pounds, which gave me an idea to build a solar-powered battery bank that could charge all of the other household batteries that I had, including my e-bike battery, in a watertight package that could sit outside, rain or shine. After spending a lot of time shopping online and a little bit of time in CAD, I had roughed out the design. The barrel would hold the solar controller, 2 batteries, and a power inverter, and include a shelf I could drop all of my various chargers and tool batteries onto while they charged inside the barrel. I spent some time in Excel sizing the system to be able to charge my e-bike battery. I won't bore you with the details, but long story short, the e-bike charger can draw more than 200 watts according to the label, up to 400 possibly, so I sized the batteries to give me enough juice to make up for whatever wattage that the solar panels couldn't provide, plus some margin for efficiencies. I ended up choosing 2 18 amp hour sealed lead acid batteries for 36 amp hours total. The math showed that 200 watts of solar panels should be enough to charge the e-bike battery when you consider the capacity of the lead acid batteries plus the solar panel output together. I picked up a cheap 2-panel solar kit with a controller from AliExpress and also a 500 watt AC inverter to be able to handle the e-bike battery charger. I copied the design for a bulkhead that I found on the internet for the MC4 connectors which came in the solar panel kit. I added a radius to the bulkhead so it would be able to mount flush to the barrel. All the parts would be 3D printed, and I designed them so they could be snapped together to hold everything in place inside the barrel. This would end up using a full spool of PETG filament. Batteries came the next day, but the panel and the inverter took over a month to get to the UK. The panels were coming from the Czech Republic, and the inverter was coming all the way from China, so I can understand. With the panels came the solar charge controller, some MC4 adapters to join the panels together, and some battery clamps that I wouldn't end up using. There was plenty of wire if I wanted to mount the kit on an RV, and altogether it had everything I would have needed to run it as a solar system minus the batteries. The first thing I printed was the bulkhead itself. This would be the feed for the solar panel wires to get into the barrel. I got a couple of O-rings that were the right size for the MC4 connectors out of my kit. I removed the nut from the connector and then added the O-ring over the threaded portion. After passing the connector through the bulkhead, I threaded the nut back onto the connector. It was rigid and hopefully it'll end up being waterproof. I repeated it for the other connector. After that, I cut a paper template of the bulkhead to transfer onto the barrel. I pasted the cutout on the barrel and then traced a cut line for the hole, and I ended up just using a utility knife instead of a saw because the barrel was pretty thin and I was too lazy to get the jigsaw out of the shed. I placed some silicone tape on the joint and I installed the bulkhead with some tape over the top of it temporarily. I screwed it to the barrel with a couple of self-tapping machine screws and cut away the excess silicone tape. I really should have marked my screw holes, but I think symmetry is overrated anyway. Next, I started all the other parts printing. My 3D printer isn't the biggest, so I had to get creative with slices and cuts to minimize the supports and then to split everything in parts that would fit on the bed. These parts took several days to print overall. I used a complete 1 kilogram spool of black PETG, and when I ran out printing the last side panel, I had to switch to some leftover orange filament. While those parts were printing, I started checking how they fit into the barrel. The base plate was 2 halves made from 2 pieces each, the plate itself and then a spacer on the bottom. Together they're supposed to hold the batteries in place in the bottom of the barrel. The only problem is that I made a mistake in my measurements and it doesn't fit quite right. If only there was something that could get me out of this difficult situation.
Vin Diesel is Triple X.
The things I'm gonna do for my country.
This massive can of spray foam was only £4 on Amazon. And I'm not sure if it's just a UK thing, but this can came with some disposable gloves inside the lid of the foam. This is a brilliant idea, especially considering I usually end up getting foam everywhere except for where I want it. I do feel like a lunch lady, but at least nobody will end up with hepatitis. I filled the bottom of the barrel with spray foam to take up the extra room. The foam propellant was aggressively loud and I used way too much of it. I popped in the battery tray, but I realized I was making a big mess. With my new lunch lady powers, I scooped out a few helpings of the forbidden tapioca. After putting the batteries in to hold everything down while the foam cured, I looked at the Triple X mess. It was everywhere. Let that be a lesson to all of us. A little prophylactic can prevent a sticky situation from turning into a big mistake. The rest of the parts had finished printing, so I installed the solar controller onto the least spooky side panel with a few screws. The circuit layout is pretty simple. First, I'll make some wires to connect the battery terminals to the solar controller battery input. The battery's connected in parallel so that I have the higher current capacity but operate the controller at 12 volts. The inverter connects to the output of the controller, and then the solar panel voltage will be coming in through the bulkhead connection and into the controller. Time to wire it up. Let's do a magic smoke check. Brilliant. Now it's time to live with the consequences of my earlier poor choices. I've heard people scraping the bottom of the barrel for content, but this is a new low. After a little bit of elbow grease, the tray is clean enough for a trial fit. The batteries were slippery, bulky, and heavy all at the same time. I tried a few times to drop it all in, but ended up having to remove one of the batteries to do it. I cut the solar panel wires to length to get the excess out of the way inside the barrel. Make sure when you do connect them to get the polarity right. It was awkward working in a barrel like this. I may try to improve the design to put the battery assembly on a caddy that I can then drop in the top, and that would make this a lot easier to put together. Once the solar wires are installed, I plugged the solar panels in to be sure that everything was working as expected. I'll make some extension cables for this later. It was a pretty overcast day, but the controller detected the solar panels and did appear to be charging. I hope you appreciate the views of the back of my head, because working inside a barrel with a camera above you isn't the easiest thing to show. I'm connecting the wires to the inverter, which is the last little bit of wiring to do. Once I'd twiddled the nuts into place, I had some trouble pushing the upper closeout shelf down over the top of the batteries. I hadn't left any reliefs for the wires in the CAD drawing, thinking there was enough room around the batteries that it would be okay. I struggled for a while and then even managed to draw some blood on a sharp edge of the 3D print. But in my experience, drawing blood is usually good news for a project. If everything goes perfectly, it means you've forgotten some critical part and it's going to explode the first time you turn it on. I tried to cut some clearance with my side cutters, but it wasn't enough. Once again, it looked like it was time to cue the metal. Even after that, the clearancing still wasn't perfect, but it was pretty close. I struggled to get it to sit onto the batteries properly, and I ended up just kind of staring at it for a few seconds. After a little bit more trimming off camera, it finally fit, more or less. I definitely want to improve the design after this experience, just to make it fit a little bit better around the cables. I installed the rest of the closeout pieces, and finally everything was more or less in place. Next, I needed to make some extension wires for the solar panels. The connectors are pretty straightforward, just make sure you put the right pins in the right connectors. The female connector gets the male bullet pin, and the male connector gets the female bullet pin. I didn't have the right crimping tool, so I just made do with some irrigation clamp pliers that I had lying around. Put the nut, the locking ring, and the rubber gland onto the wire, and then push the pin into the connector until it seats. It'll click in very solidly. Then you can screw on the nut and retain everything else in place. A few days prior, I had printed some mounts for the solar panels. Originally, I had a design that would screw into the shed through holes in the roof, but to avoid drilling holes and potentially causing leaks, I ended up going with magnets instead. This also lets me remove the panels pretty easily if I need to. The magnets were installed partway through the 3D print, and then the rest of the part was printed on top. They aren't super strong magnets, but they're good enough for my purposes. After screwing them onto the panels, it was easy to stick the panels to the steel shed, which brings us back to today. I connected the new wires I just made onto the panels, and then to the bulkhead on the barrel, and that's everything connected up. Let's test it out. Power's working, and this is the battery from my string trimmer, and it will be charged straight from the energy stored in this little blue barrel. One side benefit is that I can charge all of my batteries in a place where I don't have to worry so much about a fire. While I always try to buy quality batteries, anything with a really big capacity, especially my e-bike battery, does have a risk of starting a big fire if it's charged indoors. By doing it this way, the only thing I'll lose other than the battery is a small cylinder of stored sunshine. And there you have it, sealed up tight and ready for use. If I need some portable power, I can disconnect the bulkhead and carry it anywhere. I can use it on a camping trip, or to mix margaritas at a tailgate, or as a battery backup at home. And later I could spring for a much bigger lithium polymer battery for more capacity. For now, it will quietly whir away, turning sunshine into electrons until I need it. The total cost, however, was not that great. It was £286 for the battery, the solar kit, and everything else. But solar energy is free, right? As much as you want. as long as it's daylight and it's not cloudy and you pointed the panels in the right direction. So let me think. At 40 pence a kilowatt hour is what I was paying in the UK earlier this year. I'm only going to need to generate 715 kilowatt hours out of this to break even. So I'll need to leave it in the sun for 3,575 hours, or 149 days of continuous 24-hour sunshine. In terms of real days of sun in the UK, that's not great. That's about 2.5 years to make the money back just in power cost. On the plus side, the day after I finished the build, the rain came back. Let's see how it did. Let's see if it worked. Some water. Miracle. It's even still charging, even in the overcast. Nice. Call that a success. If you enjoyed this video, take 2 seconds to click the thumbs up and subscribe to this channel. If enough people find this content interesting, I might finally have a reason to make the Hardway Hobby Shed a little bigger. Thanks for watching, and remember, keep your tools oiled and your head dry.